Okay so far? All right. So let me get to the last one. And the last one is the scariest one, and it's called reduce. Okay. Now what is reduce? And in Scala, reduce has a different name. It's called fold. So in Scala, we talk about fold, but in other programming languages, in the context of Hadoop and Spark, it's usually called reduce. Okay. But we will call it fold because that's the operation that Scala calls it fold. So that's the third functor we are going to learn. Okay. And so far, every functor we have learned has this idea that you are applying something to every element of the list, and then you are collecting up the result, which is typically also a list. In fact, it's always a list. So map applies a function to every element of the list and returns a new list, which is the result of all the applications collected up into a list and given back to you. Right? Filter applies a predicate to every element of the list and returns a new list which consists of only those elements that pass the predicate, that say true to the predicate, and you return a new list. Now let's look at a function that aggregates operators. So the idea is if you want to do a reduction operation, which is usually like doing a summation or doing an average or doing some operation that takes all the elements of the list and combines them into a single number or a single string, right? So smashes them together into a single thing. And that part operation is called fold. Okay? A typical fold operation is sum up all the elements in the list. Take all the elements in the list, add them up together, and give me the result. Or take all the elements in the list, make them into strings, separate them by commas, and give me a new string which is a comma separated string of elements that you may want to print. So those are examples of fold operation or aggregation operations where you are taking a entire list of things and then aggregating them into a single element or a single thing, not a list of things, but you could also do fold where the result is a new list. But typically fold is imagined as an operation of adding things, subtracting things, or adding all of them up together, multiplying all of them up together. Okay? Those are typical ways you imagine the fold operation or the reduce operation. All right, so let me give you an example. And first let me draw a picture before I give you an example. Before that, I've stopped sharing screen. Okay. Filter and map. Okay, good. That's correct. Perfect. Thank you, John. So let's do this. Let me share my screen, my iPad screen, and let's look at how fold looks. Hopefully that worked. Hopefully you can see the screen. Let me talk about fold. And in the case of lists, there are two fold operations, something called fold left and something called fold right. So let me talk about both operations and then give you examples of fold left and fold right. Okay, so the idea here is this. You have a list of elements. So let's call these elements A0, A1, 2, A sub n minus 1. So you have this list of numbers. Think of them as numbers if you want. Okay, and you are applying an operation called fold. It can be a fold left or a fold right. I'll talk about this in a second. And the idea here is the fold operator has two things. So you say list dot fold, and a fold has two arguments. The first argument is something called an accumulator. It's the thing that's going to accumulate all the results. Okay, it's all the results are going to get accumulated into it, and that's the accumulator, and it's always the first argument of fold left. The second argument is the current element that you are processing. So let's do this. So this is going to be list.fold left function. This function has two arguments. The first argument is the accumulator. The second argument is the current element you are processing, and the result is the new accumulator. Okay, and the idea here is this. So fold left should basically start with an initial value of accumulator. Let's call this accumulator 0. So you have to give that as an argument as well. So I'm now adding more stuff to my fold. Okay, sorry about that. So it should really be this list.fold left, my initial value of accumulator and a function. And the idea here is you are applying the function on accumulator 0, A0, and that gives you accumulator 1. So you take A0, you take the initial value of the accumulator, you apply, you get a new value of accumulator, and then you apply the function on accumulator 1, A1, and you get a new value of accumulator, accumulator 2. You get function accumulator 2, A2, and you get A3, accumulator 3, all the way until you end up with function accumulator n minus 1, a n minus 1, and you would get accumulator n, and this is the result of the entire fold. That's a little bit too much. This is why people hate fold, because you have to imagine what fold does in your head, and it's a little too much. So I'm going to explain this in terms of different types of accumulator functions, different types of accumulators, and you tell me what fold achieves. All right? So let's start with simple examples. So let's take a function. So let's take list. Let's take fold left. And I won't talk about fold right, because fold right is just folding from the end of the list to the beginning. Here, I'm folding from the beginning of the list to the end. Okay, so suppose I take list fold left. My initial accumulator is 0. And my function that I'm going to use is the function that adds two numbers. It just takes two numbers and just adds them up. Is that good? Okay. So now think about what this function does. So suppose I had a list. Let's call this list 2, 3, 4, 8, minus 5. Suppose this is my list. Okay, so this is A0, A1, A2, A3, A4. So imagine what fold is going to do. So first it's going to apply fun on accumulator 0, A0. So what is fun? Remember, fun in this case is just adding two numbers up. So what happens if I add A0, which is 2, and accumulator 0, which is 0? What happens if I add them up? I get 2. So this is my new value of accumulator. So this is accumulator 1. Now what happens if I do fun accumulator 1, A1? So this is just taking 2 and adding it to 3, and this is going to give me 5. Is that good? So I'm just going to take the accumulator, apply the function to the current accumulator, to the current element. I get a new accumulator, and I keep going to every element in the list. And that's called folding. Question? Oh, why does it need an accumulator? Because the idea of fold is like this. You're taking an entire list and you're mashing it up. You're taking all the elements and you're doing some operation and you're accumulating some value and you're printing that or returning the final accumulated value. And that's what the purpose of fold is. So you need, before you start, you need an initial value of the accumulator. Before you start all the operations, you have to give me an initial value of the accumulator, okay? And then fold applies that accumulator to each element of the list, updates the accumulator, and keeps going. Okay? So as an example, so if I wrote this list.fold left, okay, and I said accumulator 0 and fun, this is equivalent to some code. What is it equivalent to? So its equivalent code is like this: var ACC equals accumulator 0. So create a var, call it accumulators ACC, and give it the initial value of the accumulator, and then do a loop. So for each element X in the list, or let's call this AJ in the list, this is just pseudocode. This is just pseudocode. I can make it Scala-like code, if you will. So this is just saying iterate through the list, go through every element in the list for each AJ, then do accumulator equals fun of accumulator, comma A sub j, and at the end of this, return accumulator. So this whole thing is replacing, list.fold left, initial value of the accumulator, and this special function, this two-place function, first argument is accumulator, second argument is the current element of the list, and the return value is the new accumulator. Is that okay? Let's see. Yeah, if I'll read the chat. Okay. Is this done with tail recursion under the hood? Yes, it is done with tail recursion under the hood, or more pointedly, it's done by whoever implemented the underlying data structure. If it's a complicated data structure, whoever did that is doing that under the hood. What you are looking at in Scala is at a higher level of abstraction. You're just writing it as a fold. Why does this need an accumulator? Why can't it just be the starting elements of the list? Yes, actually, Andrew's question is really good. There is a version where it's just the starting elements of the list. I have to read the API. The version I like to teach is just one simple version where it's just the initial value of the accumulator. If you wanted the version where it's the starting element of the list, you would simply say list.fold left, and you would simply say list.head, and you would say, and this would become, instead of list, you would call it list.tail .fold left. So you can do your logic that way, but there is a special function that allows you to do that. You have to read the list API for that. This is only for ints, right? No, it actually works for everything. So I'm going to show you some examples with ints. I'll show you some examples with strings. I'll show you some examples with lists and so on. Okay, so I'm going to transfer over and show you some examples. Okay, show you lots of examples so you get an idea of how this all works. Okay, everyone okay with fold? Fold right, on the other hand, moves from the right of the list all the way to the beginning of the list. We will not get much of an opportunity to use fold right. For list, I would just use fold left. Okay, fold also works on other data structures like map and set, and there you might not call it fold left or fold right, because this idea of going from left to right or right to left doesn't exist in some data structures. In a data structure where there is no order, you might not have this notion of going from left to right. And in those data structures, you would just find the operation called fold. It won't be called fold left or fold right. So you have to look into the API. So if you look into the API, you will get a clue of what kind of operation are we talking about. Okay, so let's give an example. So fold to add all the elements of the list. Number. So here I want to say def add all. List is a list of numbers, and I want to return a number, which is the sum of all the elements of the list. And here I would simply say list.fold left. The initial value of the accumulator is 0, and my function takes an accumulator and an element and returns accumulator plus element. Okay, so you see, this is the initial value and this is the function, and the syntax for fold is list.fold left, and its initial accumulator value, and the function, anonymous function or even a named function. Okay, that function has to be a function that takes you in from an accumulator to the current element of the list to the new accumulator. Okay, so right now this is it. Now why didn't I write it like this? If it's a function with 2 arguments, why couldn't I just write initial accumulator value comma function? Okay, the idea here is it's a very special kind of syntax called, I'll give you the name and I will explain that later. It's called curried syntax. Okay, you're doing something called currying. What does it have to do with Indian food? Nothing. It has to do with a mathematician or someone logician called Haskell Curry, and we will visit this at some other time. So the idea here is, instead of writing a function as function of a comma b, you're writing it as a function of a of b. So you're writing your 2 arguments in 2 separate brackets, one after the other. Live with it for now. think of it as some strange quirk that fold left has been given this curried syntax. I will clarify this later. There is a reason why you give it a curried syntax, and I'll talk about this later. We'll talk about currying and all that. Okay, it comes up somewhere in this class, maybe 2 weeks from now or 3 weeks from now. It comes up. We'll talk about that. Okay, so good so far. All right, so what does this function do? It adds all the numbers in a list. So as an example, add all list of 1, 2, 3, 3, 4, 5, 6, like that. So by the way, if I want to create these lists, I can simply say 1, 2, 6 dot to list. Okay. If I wanted to just generate a list from 1 to 6, I simply say 1 to 6, which is a iterator from 1 to 6, and I convert that to a list, and that gives me a list from 1 to 6. And I can do something like, okay, so you can do all of that. You can do all of that. Okay, so that's add. Now how about multiply? So if I wanted to multiply, how do you do that function? So what about multiply all the elements in a list? So multiplying all the elements, what should be the starting accumulator value if you want to multiply everything? Is 0 okay to start? No, right? You want to start with 1 because multiplying by 0 defeats the purpose. Everything becomes a 0. So you multiply by 1, and instead of accumulator plus element, you would say accumulator times element. Okay? So as an example, you can say def factorial of n equals 1 to n dot to list, and then you call multiply all, and this is a very slick way of writing factorial. Okay, so this is just creating a list of all numbers from 1 to n, and this is just calling it to multiply all, and it's just multiplying all the elements using fold. Okay, good. So these are simple uses of fold. Let's go into slightly more evil, complicated uses of fold. So I want to take a list of strings. So fold has nothing to do with just ints. It can be applied to strings too. So let me take a list of strings. So example, I want the input to be like a list with hello, world, help, fold, killing, something like that. So you have this list, and what I want you to do as an output is a single string, which is hello, comma, world, comma, help, comma, fold, comma, killing. Okay, so I want a single string that's just a comma separated. So concatenate all the elements with a comma. There is a function, inbuilt function for this, but I'm just going to write it using fold. Is that okay? So this is a fold on string. So what's the idea here? The idea here is this. So you say define concat with comma. List is a list of string. My output is a single string, and I'm going to say list dot fold left. What's the initial value of my accumulated string? It's just the empty string, right? I heard empty, good, empty string. And then the anonymous function is going to go like this. It's going to take an accumulator, which is a string. So accumulator is a string. My list element is a string. Okay. And what I do is I'm going to say just take the accumulator plus a comma plus a element. Okay, so just take the current accumulator, put a comma at the end, and add the element. It's not quite doing what I'm going to do, so I'll change the specification because I am the professor and I can change the specification. All right, I will later fix this, but right now look at this, and so you can say that. Okay, and now you can say concat with comma, and you can concatenate all the elements in this list, and you get this comma hello, comma world, comma help, comma fold, comma killing. Okay, so here you can read this function, right? So its initial value of the accumulator is empty. Every time you get an accumulator and an element of the string, take the current accumulator, put a comma at the end, snap on the element of the string. Okay, good. Now let's do some, so now you can do fold on a string. You can do more complicated operations. Question? Yes, fold right would just work in reverse, except for one thing that always gets me. So when you do fold right, okay, so this is, by the way, I'm not going to work too much with fold right. What happens is you still have the reverse thing. You're coming back from the end. The one thing you need to do, I believe, is this. So I believe that in the function you write, the element comes first and then the accumulator comes. So it's like the accumulator is coming from the end, right? So the accumulator would become the second argument. Or maybe because I spent the summer doing like a different language called OCaml, I might be wrong, but just let's do this and see if it works. Okay, it looks like, yes, it works. So remember, in fold right, the accumulator comes as a second argument. This is confusing, so I just don't bother with fold right just yet. But when you fold right, the accumulator is coming from the end to the beginning. So you think of the function you're applying as the element first, accumulator next. When you do fold left, it's flipped over. Accumulator is coming from the beginning to the end. So you think of the accumulator first and think of the accumulator as this big character that's eating all the elements in your list and growing from the left. So each function is accumulator element and then eaten, accumulator element and eaten. I guess you haven't played Pac-Man. Fine, different generation. I can't help you with that. Maybe I'll find something else to give you this idea, right? So if you played Pac-Man, it's like this character that's eating your element from the left to right. Each time it eats, it grows, and that I imagine that as accumulator. But fold right, accumulator is coming from the right to left. So in the function, the element is first, accumulator is second. Okay, I am done for today. I have a lot more examples of this in the notebook. I still have a little bit of things to explain here, so I will start the next lecture with that. The tutorial will explain a lot